right, good morning. This is Professor Grenfell with another video in my lecture series for Math 12, Statistics. And today we're beginning into Chapter 5 on probability distribution. So as an introduction, many decisions in business, insurance, other real-life situations are made by assigning probabilities to all of the outcomes in a situation and then evaluating the results. So for example, I might receive a tip to buy a particular stock because it is predicted to increase in value by 3%. So that information was probably found by using probability theory. So in order to analyze our results, we will be utilizing a tool known as a probability distribution. In order to make one of these, we're going to make a frequency distribution for the number, all of the outcomes of this variable. We're going to find the probabilities for each outcome, and then if we need to, other than just a chart listing the probabilities, we can graph those by representing those with vertical bars. In example 5-1, the theme is rolling a die, and it says to construct a probability distribution for rolling a single die. All right, we'll make a table consisting of a row for our outcome, and we'll call those X values. And so here they are for rolling the die. We could get a 1, 2, 3, or 4, or 5, or a 6. And then in a row below this, we'll go ahead and compute and then list all of the probabilities for each one of these outcomes. And here, rolling a die, there's only one 1 on the die, so we have a 1 out of 6 chance of rolling it. Similarly, a 1 out of 6 chance for rolling a 2, 1 out of 6 chance for rolling a 3, 4, 5, and so on. All of these are equally likely. It's a fair die. And if we want a graph, we can say the probability on the y-axis, the outcomes on the x-axis, and we'll represent each one of those outcomes. There they are, the potential values for our dice roll. And here are the respective probabilities. So this is 1/2, and all of these bars are 1/6 in height. We could draw this more similar to a histogram where our bars are connected, or I've drawn it here with them separated. In example 5-2, pertaining to tossing coins, it says to represent graphically the probability distribution for the sample space for tossing 3 coins. So first, we're going to come up with our probability distribution, and then we're going to make a graph of it as well. So for our random variable, we'll say that that is the number of heads that we observe when we flip these 3 coins, and then the probability is going to be listed below. So our outcomes is we could have 0 heads, 1 head, 2 heads, or all 3 coins land head side up. All right, 0 heads, that would be one way to do that if we flip all 3 tails. And similarly, to get 3 heads, we'd have to flip all 3 of them heads. So there's only one way to do this out of 8 possible, and one way to do this one out of 8 possible. To get exactly 1 head, we could we could have the last one come up heads, we could have the middle one come up heads, or we could have the first one heads and the second 2 tails. Right? So there's 3 out of the total 8 possibilities there. And then to get 2 heads, we just sort of reverse this picture. Heads, heads, tails, heads, tails, heads, and then tails, heads, heads. And all 3 of those would be distinct, but all 3 would yield 2 heads. So there is our probability distribution chart, and now we'll graph it to represent graphically. All right, the graph of our probability distribution on the x-axis, we're going to have the outcomes for our variable x. We're going to list the probabilities on the y-axis going vertically. And so for this first outcome of 0 heads, we have a probability of 1/8. Same for this third outcome, getting 3 heads. And then these ones here have a probability of 3/8 each. So this bar is extending up to 3/8 here. And this bar as well is extending all the way up to the height of 3/8. All right, in this next situation, we're going to be doing an example 5-3, talking about battery packages. It says a convenience store sells AA batteries in 2 per package, 4 per package, 6 packs, or 8 packs. Over the weekend, the store sells 5 2-packs, 10 4-packs, 8 6-packs, and 2 8-packs. Construct a probability distribution and draw the graph for the variable. So we have the frequencies. I've gone ahead and totaled up those frequencies. So we have a total of 25 packages of batteries that are sold. And I'm going to go ahead and construct the probabilities, or compute the probabilities for each one of these outcomes. So we'll take the frequency for that outcome divided by the total frequency for the whole sample. So this gives us 1/5, or 0.2. This would give us 2/5, or 0.4. This one works out as 0.32, and this last one is 0.08. And so I've set up my graph here, and we're simply going to go ahead and place in the correct height bars. So the first one is 0.2 in height. The second one goes all the way up to 0.4, so it's twice as high. The third one here goes to 0.32, so we're just going to kind of estimate that. It's a little bit higher than 0.3. And then similarly, 0.08 is just going to be a little bit under 0.10. So that is our frequency distribution. I mean, our probability distribution. All right, real quick, requirements for a probability distribution. The first one is that the sum of all of the probabilities has to be equal to a grand total of 1. And then second, each of the individual probabilities has to be between 0 and 1 inclusive. All right, in this next example, here is example 5-4 on probability distributions. It just simply says to determine whether each distribution is a probability distribution. And so, essentially, we have to just make sure that it satisfies these 2 requirements, that the sum of all of the probabilities is equal to 1, and each individual probability is actually a valid probability itself. Remember, in order to be a probability, that number has to be in between 1 and 0, inclusive. All right, let's look at part A. Part A, right here, is not a probability distribution because the sum of the probabilities, 0.3 plus 0.4 plus 0.1 plus 0.2 plus another 0.1, is equal to 1.10. And so that is unacceptable. It is not an actual probability distribution. It just kind of looks like one, but it's not. Okay, part B is a valid probability distribution because 1/4 plus 1/2 plus an 8 plus another 8, that adds up to a grand total of 1. And each one of these fraction values is a proper fraction in between 0 and 1 inclusive. Next, part C, exact same reasons. A quarter plus a quarter plus a quarter plus a quarter is exactly 1, and all of those are perfect, proper fractions. All right, part D is not. Can we see why? Yes, negative 0.6 is not a valid probability. So it is not in between 0 and 1. It is less than 0, negative. And then furthermore, all of those probabilities are not going to add up to a grand total of 1. So that last one, D, is sort of double disqualified.